Hello friends, welcome in the next lecture of Physical Chemistry, subject CHP-110 Fundamentals of Physical Chemistry. Now today in this lecture we have to study the next some terms used in thermodynamics. In previous lecture we saw some terms such as system, surrounding, boundary, then some processes. So all these terms we have studied in last lecture. Some few terms remaining which are useful in the study of thermodynamics that we have to study in this topic. So next term that we have to study is a state function and path function. So state function that we have to study. State function is we know that in the last lecture we saw state variables. What are state variables? Value of which defines the state of system, such as we say initial state, final state. So state of system is defined by some variables, some parameters, and these are nothing but state variables, and they have some value. If they have a fixed value, then it is called as a state of system, that is initial state, final state. So initial state, final state is defined by state variables such as P1, V1, T1. So it is initial state. So value of pressure, volume, value of temperature defines the state of system. They are now not change with time. That's why it is a particular state. So these are state variables. So we have to define state function. That is state variables. If state variables are determined by initial and final state of the system. Initial and final state of the system, and not path forward. State variable depends on initial and final state of the system. That is called as state function. It depends only on initial and final state of the system and not the path forward. The function are called as state function. Second, see path function. Path function, these are state variables which depends on path followed. Then these functions are called as path functions. So state function depends on initial and final state of the system, and path functions depends on which path the reaction process follows, and that path followed functions are called as path function. So let's see some an example. You will understand the difference between these two, state function and path function. So see, if system is at initial state, okay, and after some time, if system is at final state, okay. So if P1, V1, T1 are some initial variables, P2, V2, T2 are some final variables. Okay, so system changes from initial to final state by two paths. Tell this one path, the another path. Okay, suppose consider the expansion of gas or compression of gas, expansion of gas from initial state to final state by two ways. First, by adiabatic process, and second, stepwise. Two paths are there to reach the final value, that is final state, initial to final state, by adiabatic process and by stepwise. Okay, we know that what is adiabatic process. In the last lecture we saw this term. Adiabatic process means the process in which no heat allows to enter the system or remove from the system. So Q remains constant. Q is equal to 0 for this process. Q is equal to 0 for this process. So suppose work is indicated by symbol W and heat is indicated by symbol Q. It is indicated by symbol Q. So we have to see the difference between state function and path function. Okay. So the work and heat, these are notations for work. This is notation for heat. When the system changes from initial to final state, the total value is same, but the if path changes, that adiabatic process Q is equal to 0, and here if the process took place stepwise, then Q having some value. Heat changes took place here stepwise, the process takes place stepwise, and work having some other value in the process, but W is not equal to Q here. W is not equal to Q here. So work and heat means system changing from initial to final state. System changing from initial to final state by two ways, two paths. Okay. So heat by this path, heat exchange is 0, heat Q is equal to 0. By this path, Q having some value. But what system changes from initial to final state means total value remains same, but this quantity changes according to the path. If adiabatic path follows, then Q is equal to 0, W having some different values, Q is equal to by stepwise process, Q having some value, W having another value, but these two are not equal, and if path changes, the value of these quantities changes. That's why these two quantities such as Q and W, work and heat, are path dependent. If we change the path, then there should be change in these quantities. So these are path dependent quantities, and path dependent quantities are called as path functions. So examples of path functions: W is a path function, Q is a path function because they changes according to the path. See another quantity, that's internal energy of system. Internal energy in both the cases, if you follow this path or either this path, internal energy of system remains same, and it is represented by delta E. So internal energy of this system remains same, and that is delta E. When it will be same? It will be same only when it is dependent on initial and final state only, and not path flow. If it changes according to the path, then there will be no constant value obtained for delta E. Delta E is constant for this process. That means it does not depend on path. It depends directly on initial and final state of the system. So difference of initial and final and initial state gives the constant value. So it is a state dependent function and not path dependent function. So state function delta E is a state function. Another free energy is a state function. Entropy is a state function. Enthalpy is a state function. So these are state function, and it is denoted by this difference. Remember this is denoted by this difference. So state function denoted by the difference, because all the state functions are dependent on initial and final state of the system. And here path functions are path dependent, and they are denoted by total quantities. They are denoted by total quantity. So this is the difference between state function and path function. And if we think about this work and heat, why this work and heat are path dependent? Because at initial state, suppose that I am taking a general example here. If you are at state B and after some time you are at state B. Okay, I am taking an example of work here. So if you are at state A and then after some time you are at state B, some another destination or another point, you are at point B. When you are at point A, means if you stand here at point A, then your work done will be 0. Okay. After some time, if you are at point B, you stay at point B, then W is equal to 0. If you are standing here, there will be no work done. If I am moving from one point to another point, then there should be some work done. Okay. If I am here at point A, then there will be no work done. I am staying here, so there will be no work done. And after some time, I am at point B, where there is no work done. But when work start, when person moving from point A to B. Okay, so while moving A to B, work is done. Work has some value. If you are moving from one point to another point, you are doing work. Okay, you are moving there. Your processing with some energy. So work is done during the process. So that is a quantity. Work is a quantity which occurs during the process only. That's why it is a path functions. And if you go by this long way from point A to B, the work done is different. If you use the shortest way, then work done is different. If you use another way, then work done is different. Means this work done is different for every path, because it depends on path flows and it occurs only during the process. And when the process stops, or it may be at a particular state, there will be no work done or no heat exchange took place. That's why these quantities are path dependent quantity, and these are called as path functions. So this is the basic difference between the state function and path function. State functions are depends on initial and final states only, and they are indicated by this difference delta. So delta E, delta E, delta S, delta H, these are state functions. And another path functions which are having total quantities such as W, Q, which occurs only during the process. During the process, and when process stops, these quantities having no value. So that's why such as delta Q, delta W has no values, because they are occurs only during the process and not initial and final state. That's why they are not represented by this delta symbol. They are always represented by total quantity, and these state functions are always represented by the difference. Okay, so this is about state function and path function. Now next quantity, next point that we have to study, next term we have to study in the thermodynamics. In thermodynamics, is the thermodynamic equilibrium. Thermodynamic equilibrium. When we call system is in equilibrium, system is in equilibrium if macroscopic properties of the system does not change with time. Macroscopic properties of the system, if does not changes with time, then that system is said to be in equilibrium. So system is said to be in equilibrium when macroscopic properties of the system, such as macroscopic property pressure, volume, does not changes with time. As time goes, if these properties does not changes, then there should be no change of these macroscopic property with time. Then we say system is in thermodynamic equilibrium. No change in macroscopic properties, then system is said to be in equilibrium. No change in macroscopic properties with time, the system is said to be in thermodynamic equilibrium. We have to consider two types of equilibrium, that is mechanical equilibrium and second chemical equilibrium. Means there will be no change in particular quantities, then we say the system is in equilibrium. Here in this case, see mechanical equilibrium. Mechanical equilibrium. What happens in mechanical equilibrium? In mechanical equilibrium, which quantity? Mechanical means we are doing some work, okay, mechanically. So there will be no change in work, no change in work with time. No change in work with time, then system is said to be in mechanical equilibrium. If there will be no change in work with time, then system is said to be in mechanical equilibrium. What is chemical equilibrium then? Chemical equilibrium, what happens in chemical equilibrium? In chemical reaction, there will be change in concentration. In chemical equilibrium, there will be change in concentration. So concentration of phases and phase change takes place here in chemical equilibrium. There will be no change in concentration of any phase of the system with time. Then the system is said to be in chemical equilibrium. System is said to be in chemical equilibrium. So mechanical equilibrium is what? Mechanical equilibrium is there will be no change in the work with time. The system is said to be in mechanical equilibrium, chemical equilibrium if there will be no change in concentration of the components of the system or reactions of any phase with time, then that system is said to be in chemical equilibrium. So these are types of equilibrium. Next we have to see the thermodynamic processes. These are important while understanding some concepts of thermodynamics. So thermodynamic processes. What is thermodynamic process? Thermodynamics process when system, the path or operation by which system changes from state 1 to state 2. Path or operation by which system changes from one state to another state is said to be thermodynamic process. Okay, by some path, we saw here system changing from one state to another state. So system changes from one state to another state. So while changing this system from one state to another state, it follows some path or there will be some kind of operation there, and by which system changes from one stage to another state. So that is a thermodynamic process. We have to see some processes, thermodynamic processes, types of processes. So different types of processes are there. Isothermal process, adiabatic process, isothermal process, adiabatic process, isothermal process, adiabatic process, isobaric process, isoporic process, isoporic process, reversible process, irreversible process, okay. So these are the types of processes. These are the types of processes, thermodynamics processes. Okay, so these are thermodynamics types of processes. We have to see one by one. Isothermal process, adiabatic process, isobaric process, isoporic process, reversible process and irreversible process. So see isothermal process. What is isothermal process? Isothermal means in this process there is no change of temperature in the process, throughout the process. So this process is called as isothermal process. Means in this process temperature is constant. Temperature is constant means that process is called as isothermal process. Temperature is constant, that process is called as isothermal process. Okay. Second, adiabatic process. What happens in adiabatic process? There is no exchange of heat throughout the process. No heat allows to enter the system or no